Hi everyone, how are you all doing? Welcome to another episode of this blockchain related series. Today we'll be explaining how blockchain works. And if you don't know what a blockchain is, consider watching the previous episode. I will leave the link in the description. I promised today we would get a bit more technical, so I have my notepad here with me. And this is the first time that I'm using this to explain like in a video, so bear with me. I'm not the best drawer in the world, but I'll keep things simple. So let's start here in opening the notebook. Forget about the concepts of distributed ledger and stuff like that. Let's just take a look at the word blockchain. As the name implies, it is a chain of blocks. So just let me draw here. Chain of blocks. So this is what a blockchain representatively looks. And what is inside of each block? Let me see if I can draw something rather decent. So each block has inside of it data, and will depend on each blockchain. For example, the blockchain, the Bitcoin blockchain has the information of the sender, the wallet address of the sender, the amount to be transferred, and the address of the wallet of the receiver or destination. Okay, so that's the first thing that a block has. What is the second thing? Okay, 1, 2, 3. Probably it's a good idea to name this one. Second thing, it has a hash. And you're all thinking, what is a hash? And I think this is a concept that it's more, I want to leave it for a separate video. The next episode will be all about hash functions and how they work, because I think it's a good concept and I don't want this video to be very long. And but as of right now, think of a hash as a unique fingerprint. And the hash basically is a really huge number that is unique and works as a fingerprint. This number represents the data inside the block, the information. If anything in that block changes, imagine if the transaction is different, if the sender is different, that will have a completely different hash. And that's all you need to know as of right now, because today we will not get super technical. I want this to be like baby steps. Each episode we get more specific. And the third one is the hash of the previous block. Ta-da! And you can now see that how they are connected because of this last one. And let me just redraw. Let me erase everything. Okay. And let's draw a better blockchain. Here we are. This is block number 1. This is block number 2. This is block number 3. And we have here hash. And we can just say this hash is going to be 1, 2, 3, D. And the previous hash, this is 000, because this block is special. It's called Genesis block. Genesis block, because this is the first block. It has no previous block. This block is special. It's the first one. That's why the previous hash is 000. And just keep in mind that hash is a really huge number. Not like this, but I'm not going to write it. I can leave an example of a hash. Oops, this is blue. I don't want blue. Okay, just let me write hash and previous hash. So previous hash is 1, 2, 3, D, and this can be like 4, 4, F5. This hash. Jesus, my handwriting is really bad. I'm sorry about that. Previous hash is 4, 4, F5, and this one can be 7, 7, G8. Jesus, why? Why are you like this? 8. So you can see, let me write like away. The block 3 is connected to block 2, and you can see the block, let me see, okay, so okay. Block 2 is connected to block 1. And let's imagine that we want to tamper with one of the blocks, if you want to double spend or something like that. I cannot draw like a hacker face, but let's just draw like a weird face, face. So if you change anything in the block, you are basically changing the information on it. So this is a completely different block, therefore it will have a different hash. And don't worry if you're not catching everything. In the next episode we will dive deeper into this, but if you do something with the block, just remember this is going to be a different block, so it's going to have a different hash. So imagine this hash is going to be 55A4. So what happens? The connection from 2 to 3, it's going to be broken. Therefore, the block 3 it's going to be invalid. And you can see where this is going. If you tamper, let me draw like a longer chain. Look at me so fast. If you tamper with this block, all of this rest is going to be invalid. So you need to change the hash of all the remaining blocks. And you're probably thinking, well, nowadays computers are super fast, right? So they can calculate hashes, and hash is calculated using cryptography, the cryptography SHA-256, but we'll leave that for a future video. And basically computers nowadays, let me draw a computer. I think it's cooler when you are drawing stuff. You have a computer, and this guy is fast. It can calculate like thousands and thousands of hashes per second. So yes, you tamper with one block, you just need to tamper the following ones as long as you have the computer powered for it. Well, that's the problem. The blockchain has a second mechanism of security, and that is called proof of work. And this concept we will leave for episode 4, but right now I just want to think of this as a mechanism. As a mechanism that slows down the creation of new blocks. Jesus, I'm so bad at drawing. I'm sorry for my handwriting. Everyone in college hated my handwriting, but never mind. And I don't know why I just erased. I'm nervous. Don't know why. This is the first time. I'm feeling judged by myself. So this mechanism slows down the creation of new blocks. So basically, in the case, let's take the Bitcoin case example again. BTC, it's 10 minutes. So each block, it's slowed down to be created each 10 minutes. So if you want to change this block, you need 10 minutes, 10 minutes, 10 minutes, and you can see like this is really completely unsustainable. But let's imagine, just for learning purposes, that you want to break the blockchain. Well, you have the security, you have like, oh, raise hash. So how can you break a blockchain? First of all, that is going to require a lot of time, because you need the computer power to be constantly calculating the hashes, and that's something that's not that easy. Then it's going to be expensive, really expensive, and we will explore this with proof of work, but this is related in costs of electricity. And third, this is if you want to break a blockchain, you need to own at least 51% of the network, and this is commonly known as the 51% attack. But then again, this is going to be, so you have hash, security number 1, security 1. It's going to be expensive. So security, Jesus, why is my handwriting so bad? Security 2, and this is related to proof of work. And it's going to require security 3. Security 3. So there's these 3 main security barriers that you need to break in order to completely destroy the blockchain. And relating to the 51% attack, because this is the one that we haven't discussed, at least we discussed in the previous episode, because this is as to relate. We already explained that blockchain is a decentralized peer-to-peer network. So there are no barriers to participants, to new participants, and each node of the network, each node of the network, each node of the network, sorry, I'm so bad, try. Each node of the network has a copy of the blockchain, so you really need to own 50% of them in order to make the new blockchain valid, and that's going to be like really expensive. It's honestly not worth it. You probably just have better uses for money. It's only if you want to break it, which could happen, but it's really like impossible, because each node has a copy, and they together check if a new block is valid or not. So if you're trying to push an invalid block, there's going to be a consensus in the nodes, and they are going to reject it in the blockchain. And just keep in mind that all of this blockchain ecosystem, because that's what we basically explained right now, is constantly evolving. So blockchain evolving. I'm not even going to try to write. It's constantly evolving and developing each year, and I'm running low on battery. This video is taking longer than I anticipated, and we'll see each other in the next episode, where I will explain hash functions. So I hope you learned something new today. If you have any doubts, just leave them down in the comments, and bye.